lots of different things there. So, all right, we got to move on.
Yep.
Uh,
thanks for the comments.
Thanks for the comments, though, because
Yep.
it makes the conversation way more
This is what it's all
interesting. Sure. Okay, this one is finally coming to you from a company called Cyclotech, and they've got a totally revolutionary, or they call it R evolutionary of motion, and it's actually unique. It looks pretty cool. Gonna roll this video here really quick, and then we're gonna give you our summary on what we actually think about their technology and how it might hold up in the EVTOL markets. So without further ado, here goes their video of their first flight of their Cyclotech. All right, so while it spins down, this is their first flight from August 20th, 2021. It looked fairly, rudimentary as far as what they wanted to do with their aircraft.
Right.
Now, a couple of things that I just want to mention. Their music, obviously, we're going to get flagged because it's not ours, so we might get, potentially demonetized on this video because of that. They have a great website with a lot of information on it. However, I'm not sure if that music was loud enough or soft enough to make us understand exactly what level of noise to expect from the actual, the development of their actual technology, number one. And I think number two, the other big thing there that's the takeaway is it is in a garage, which means it's a controlled environment. There's not a lot of variables because they're in early testing. So the only thing you can garnish from it right now is that it flies.
It does fly, yeah.
Yeah. What's your thoughts there?
It's definitely a different design. Out of the ordinary. I mean, basically thinking about how it works, certainly makes sense that it would work. If you look into it a little bit more, it talks about how it basically that the actual rotors as they spin, they can generate or they can direct the thrust 360 degrees in any way around that device, like any direction. And so that goes right along with my next thought of like, okay, we always, when we look at these things and we look at rotating components or anything that's moving outside the exterior of the vehicle, you always have to try to think about, physically, however it might unfortunately be physically damaged by birds, debris, anything that may get into that rotating component and damage its efficiency or make it stop working. And so just thinking about that too, I think, okay, having them just said it works in 360 degrees, you can't put a shroud around this because it doesn't work that way. It needs to be open,
right?
And basically any direction. So, at least now, and maybe we could ponder a little bit more. And there's many creative engineers that may be able to figure out how to maybe do that differently. But it looks like they're going to be hanging out there in the open, at least for the time being.
Sure.
They've talked about having multiple rotors at each, like, let's say, corner in case for redundancy, which again makes sense. There's certainly those things to be considered as well. So initially, it's an interesting design. I'm wondering about the sound, just like you are. I'm wondering about how much payload it actually can carry. Which obviously depends on how much weight or thrust the actual devices can hold, how much weight how much thrust they can generate.
Limits of forward airspeed is another one that I'm concerned about.
It does say that actually it gets more efficient, better performance the faster the airspeed that it gets. Which thinking about it, how the blades are oriented, it probably doesn't is certainly something you could see. I mean, I don't know. We just found this. We're kind of a late entry to the show, so I wanted to bring it up. But what do you think, man?
All right. So first off, they still don't have a solution on one of my favorite things to talk about is whenever you put something up in the air, how is it going to handle moisture content in the air and fast rotating speeds, which is going to reduce the temperature of the air operating around it. And if this thing is susceptible to icing, that's number one. Number two, the other part of it is that all this equipment where it says A New Dawn, this big silver part with all these control rods, those are fairly complex. And if the outside, exposed rotor system isn't, impacted by something, I'm wondering what the controllability standards are going to be like and how durable that equipment has to be, because it looks like to me at that level that it is fairly complex. And anytime you add complexity to a situation, you have to understand that it also adds maintenance costs, it adds downtime, it adds more parts that are lifetime limited. There's a lot of carbon fiber also in this design that it looks like it's going to have to use exotic materials in order to achieve this, which means there's an expense there. Also, the other part of it is, what are the vibrations of this system and how do they calibrate or keep it basically with a rotor system or anything that's rotational, just like balancing a tire on your car, right? Is there a moment in time where these things can become unbalanced? Is there any stability issues? Because we know that there's a lot of forces if you land a helicopter inappropriately and it shifts its balance. It can throw the certain percentage of the rotary systems out of phase and it will dynamically destroy itself. So I'm wondering if there's other parts that are susceptible to this system that are drawbacks that we don't know about yet because it hasn't been explored. And to me, it looks like it has complexity. And when you get into complex systems, you have to be available to the fact that they're more complex, the more maintenance, the more that you're going to have to go through in your development cycle in order to get out there and make it fly.
Yeah, it's interesting you just mentioned something that also about out of balance. I don't know what speed these devices rotate at. They look like they move quite quickly, and that would go right along with what he was saying about things being out of balance. I mean, one thing it's something interesting that you just find out about is when you flew helicopters. Actually, I took off one time and I was hovering away from the ramp, and a plastic bag from Publix or whatever was blown across the ramp, and just so happened it blew up in my rotor system, the main rotor blades, and just got caught on the blade. It didn't damage the blade at all.
Right.
It's just a bag. Even though my blades were going light speeds, but nevertheless didn't damage the bag. It's just the rotor, but it put the whole system out of balance.
Oh,
and
yeah.
just a plastic bag.
Oh yeah, I bet.
You're like, wow, we cannot proceed. We need to return to the ramp, and that's certainly what we did. And,
yeah.
So out of balance. But I guess where I'm going with that is there's a few things that kind of make more sense, right? You've got the weight of whatever's stuck to it, but you got the arm of how far away it's rotating away from the center of rotation.
Yeah.
And then speed, of course, the speed at which it rotates. So these things don't look like they're huge.
No.
But they look like they rotate really quickly.
But this is going to be that's going to be with scale, though, right? So
as
this system scales up, all that rotational mass increases. The force that you have to push those things through the air increases. And to speak of what Corey said, I've also been in a helicopter before that had a minor malfunction, okay? And the instrument cluster on the actual aircraft shook to the point where it felt like there was a washing machine with 2 wet blankets in it, okay? And it's an immediate offsetting, experience where you get literally 30, 40, then you're at 150 feet, and by the time you've actually pulled enough pitch, and the entire
you can't even read it anymore.
You can't read the instrument cluster.
Panel's doing this, and you're like, I can't even read it.
I can't even read this anymore. And you're like, well, we definitely have an emergency at this point, so it's going to be either emergency or precautionary landing. The question is, can we just literally turn back? And now we're over, trees, and we need to turn back to where we just were. So it happens. Yeah. So we're not trying to knock their tech, right? So
no,
not at all. What we're trying to do is introduce the questions of the things that they're going to have to hit in the not too distant future about what it's really like to fly these things from the perspective of once it's airborne, what are the challenges that you don't know? Another one's going to be, how does it really handle crosswinds? How does it handle, wind conditions where if you take this and try to put it into a smaller area, can it induce its own vortices because it's generating a certain amount of lift, which is another thing that could be a good question. Like, is there a point if this thing is traveling forward through space that the amount of air that's directed from the front one can somehow impact the rear rotating assembly, and it reduces your lift on that side? I don't know. Good questions to be asked, I guess.
Yeah, I don't know. Not sure. I mean, again, it's pretty early, at least for what we can see from them. So we'll definitely keep track and see, because I am interested. It's interesting design. We're always looking for things that are interesting and make you think, and looking at other innovative ways people try to do things that solve old problems with new ideas. It's all
Yes.
interesting, but we'll just have to see.
Okay, and I just have to say this because this is one of the reasons why I really like Jetupterra's technology, because the fact that they've done away with all this rotational mass, they've done away with a lot of these things of moving parts and these exposed pieces that have to be figured out, that need to be put together. They're just doing straight up lift. And straight up vectored lift is a really great solution, especially if you can multiply it by 10 times of what your original factor was. So it just, I have to say that because in an advantage or disadvantage situation, well, I like these guys and their ideas, because in an industrial capacity without humans on board might not be a bad technology. Still pulling for other players in the space that are going after revolutionary or evolutionary technologies in a way to produce thrust. So those are my thoughts, at least.
Nope.
Let us know what you think in the comments below. Matter of fact, if you think this is a better solution than what's currently out in the marketplace, or what you think might be the best solution to the EVTOL or urban air mobility marketplace, and if you see these guys as serious players, or if they just might not make it, let us know in the comments below, and we'll be sure to address them. With that,